Welcome, listeners, to the very first episode of It Depends video series. My name is SanjMo It, and I will be presenting to you on a very interesting topic today. This topic is PostgreSQL on the move. The question begs, why are we talking about PostgreSQL when there is so much happening in this space? So fear not, there is a lot of content which we have planned to share with you. But there's a reason why we picked PostgreSQL as the first topic. One of the reasons is that it is one of the fastest growing major database management systems in the world today. We have a rich ecosystem because it's open source. And not only is it open source, there are a number of databases that have toggled between they were open source, then they were not. But this is truly a global effort to add more functionality into the database and has a democratic way of bringing in new features. They have consistent releases, and you will see some of that today. The next reason why I wanted to talk about this is because just recently, as we saw, Enterprise DB launched their database as a service, InstaCluster launched. Some of these are preview. We've seen some exciting developments this year. Postgres 14 is going GA at some point in time later this year. And we have a few more database as a service offerings that are expected to be released in the next coming few months. So with that, I wanted to talk about what makes PostgreSQL so interesting. So let's look at what are some of the key defining features. PostgreSQL, we could have hours and hours of video content just talking about its features. I was more interested in my journey getting into Postgres and what were some of the interesting things that stood out for me. One of the things that stood out, and in fact, I liked it so much that I've mentioned it 3 times, which are extensions, and more extensions. Extension is a very unique way that Postgres has to expand the capability of Postgres without having to create a altogether different product, which then needs to somehow be kept in sync. PostGIS is considered one of the best implementations for geospatial space. If you want high availability, fear not. There's a company called Citus Data, which now Microsoft owns, but it's still available in the open source community. There are literally hundreds of open source extensions which you can just bring with a simple command that says create extension. Another one that comes to my mind is for time series. It's called timescale DB. So the next point is PostgreSQL is known as developers database. It has a number of features for developers. One of them is their support for native JSON data type. They've been added for many, many years now. With every release, it becomes more capable or easier to use. In fact, Postgres 14, which is in beta, has even changed how JSON data is accessed by simplifying it even further. So what this does is it allows me to put all my static data, let's say, I have name, age, name, date of birth, address, all in my normal relational table columns. But then my shopping history is an array of products I bought at some point in time, could go into a JSON data type. And now I can index those attributes in JSON with a single SQL command. I can join the data, which is in columns, with the data in JSON, and it just gives unprecedented amount of functionality. The last point I want to bring to your attention is the whole notion of running Postgres in Docker containers orchestrated by Kubernetes. We are no longer seeing a very long drawn effort to deploy, manage, install, upgrade databases through all kinds of different commands or logins. You can now create a YAML file. You can declare. So Postgres becomes declarative, what you want in your Postgres deployment, and then you can just run it. Kubernetes not only will deploy it, but also if for some reason there is a problem with one of the components going down, it self-heals, it identifies what's gone down, it maintains a state, and then it brings back up a new node with that component. I mentioned to you that these are a few things that stood out to me for me when I went into Postgres. Where was I coming from? Well, like many of you, my background is in Oracle databases. So I wanted to highlight a few tidbits, interesting points that I had to teach myself when I got into Postgres. So the first one is the commands are slightly different, even though they're ANSI SQL compliant, but standards are standards. They differ in different ways. In Oracle, you all know if you do a select, there must be a from clause. Even if you don't need a table, you use dual. In Postgres, you don't need a from clause. In Oracle, a delete statement does not need a from, but it's vice versa. In Postgres, you must have a from clause. Why is this even important? This is only important if you are moving from Oracle to Postgres, then you need to know these differences. But it's phenomenally important if you are migrating from Oracle into Postgres. Then you have to know these differences. Another interesting thing that stood out for me was I started seeing the vacuum command all over the place. In fact, I would see vacuum command in a database that I didn't even realize was based on Postgres. And the moment I saw vacuum, I'm like, this must be a Postgres-based database. What is vacuum? Let's look at Oracle. If you do a DML in Oracle, let's say you do a delete or you do an update. If you do that, then Oracle uses an undo segment memory structure to facilitate this operation. In Postgres, every time you do a delete or an update, inside the table, you create a new row. So the old value is still maintained, but the new versioned row is made active. After a while, you end up with what are known as dead tuples. And the space they occupy is known as bloat. So vacuum is needed to get rid of that and compress or shrink your database back to the normal size. Postgres has a number of data types that don't exist in Oracle, 64 to be precise. For example, if I have a table in Oracle, which is of the type number, and I want to move it to Postgres, I can choose between decimal, int, small int, big int, real, double precision. Similarly, there are differences in indexes. Oracle has bitmap indexes, Postgres does not. Postgres has a whole slew of indexes that you will not find in Oracle. There are many other differences that you don't see here: synonyms, query hints, the way we used to do join with a plus sign in Oracle. Those are things in Oracle which Postgres does not have. Now let's move on to something very interesting. This is what, when I show this slide, everyone wants to talk about what is the ecosystem or the landscape for Postgres. In order to explain, there are about 20 odd products here. I broke it into 3 different categories. Enhanced are the products that use the core open source base, and then they either repackage it with some special configurations or they add some extra functionality through extensions. Fork, on the other hand, takes the main core product and it branches it off, makes changes into it, and then it maintains a separate branch. Every once in a while, it has to bring that branch up to date with the changes in the core Postgres. The final category is called wire compatible. These are not Postgres databases when it comes to storage, but they have the Postgres support for Postgres operations. So your Postgres application should run out of the box on top of these wire compatible databases. Very quickly, Enhanced has a number of options. Crunchy data has been added for almost 10 years now, building out their version. Amazon, you see twice. You see Amazon in Enhanced and you see as Fork. The version you see in Enhanced is a version that is based on open source. It's called RDS for Postgres. The one you see in Fork is Aurora with Postgres compatibility. So that's why you will, if you look at these two, you'll see that they support different version numbers. Amazon Aurora actually just only recently moved to version 13 in the last few weeks. Azure, Google Cloud, IBM, they all have their versions. You see versions from Percona, from Heroku. The last four are very interesting. Ivan and InstaCluster are data clouds. So they are DBaaS vendors that provide you a number of open source products, Postgres being one of them. Similarly, you have several lines and ScaleGrid. Now, under Fork, Enterprise DB and Advanced Server is probably the biggest Postgres commercial distribution that you will find. They do Postgres more than anybody else. So they have, even though it's a fork, they have a very well-oiled machine that very quickly, when a new version comes out, it goes through their machinery and you get a new version of Advanced Server with Oracle compatibility and a number of other features. We've talked about Aurora. Redshift is also, at one point, was a Postgres fork, but they have added a number of new features into it. Then you got Greenplum, Netezza, which is an appliance, Yellowbrick Data. The only one in this list that is no longer available is Aster Data. But every other product you see is very much easily available. Wire compatible is interesting because wire compatible is probably one of the most exciting spaces in relational database management systems. This is a database that also is called NewSQL, but it's really distributed SQL. It is maintaining ACID compliant SQL-based databases that are globally distributed. That's a tough nut to crack. These are the two, CockroachDB and Yugabyte, you see, which provide you Postgres compatibility, but the storage engine is their own or it's from some other place. Like in case of CockroachDB, it's based on RocksDB, a database that came out of Facebook, which the CockroachDB has modified for their purposes. So next, we are going to take a very quick look at, if you are moving into database as a service or DBaaS, what would you want to look at? You want to look at what kind of product are you getting? Is it available on multiple clouds or a single cloud? Cost, you would think that that if you move to DBaaS, then your configuration headaches are gone. So think again, Postgres, even though you're in the cloud, cost can vary a lot depending upon how you configure it. And so it's always a very important factor to look at. Scalability varies between different versions, scale up, scale down. Almost everybody has it. Some have scale out, scale in. Some have scale up, but it's not like the next big instance size. It is more granular scaling. Some have it automatic, some are manual. So this is a very important thing to look at. Availability, under availability, I put high availability, disaster recovery, backups. Most of them actually do automatic backups now onto an object store. Some have a number of read replicas, some don't. So that's another thing to look at. Security, security is always an issue. The bigger providers have all kinds of security certifications like HIPAA, PCI DSS, some federal ones, also encryption of data, masking, and all of those capabilities vary quite a bit between different providers. Finally, a very interesting one is what version of Postgres do they support and how quickly do they upgrade you to that new version? Because Postgres is constantly getting updated. With every new version come new facilities, new capabilities. Interestingly, the upgrade piece is not as easy as it looks. A very easy upgrade is to take your Postgres database, shut it down, and do what's called dump and restore. But you cannot shut down your production database. Maybe you can in some cases, but in most cases, if you cannot, then you have to look for some online in-place migrations, and not everybody provides that. So finally, the last slide, we are not going to spend much time on this because this is a topic that needs a whole session by itself. I wanted to talk about how does one migrate from one database into Postgres. The reason I picked AWS is only because AWS has been at it for many, many years now, and they have probably the most mature and a wide array of products that allow you to do it. This is only a glimpse of what's available. We will talk about this in a future episode. So for now, thank you very much for your time. It's been a pleasure, and we will talk again. Thank you. Bye.